welcome, thank you. Yes, so I was asked to do a little presentation on Python and discovering Python. When Daniel talks about expertise, I'm always a little bit worried because I think expertise, experience, and then I think experience, anecdotes, and bias. So it's a little bit of a story I'm going to tell you about myself and where I come from and how I learned Python and the story about many people who do really cool stuff in Python. One thing I would like you to know before I start is I did not study computer science. That's not my thing. I've been making computers do things for a very long time, mostly for fun, sometimes for work, and more often than not to help me do my work, which was not really software engineering related. I'm not lying. A few years ago, I bought that book because I really felt like I needed to brush up on the basis. If you are in the same if you're like me, like if you like computers but you don't study computer science, like it's really awesome to have pep talks with people who do study computer science and not look like a fool. Where did it all started? It started in 1983. Yeah, that's me. I saw a movie called War Games, which was absolutely awesome. You had a bunch of kids riding BMX and making stuff with computers and about to start a nuclear war. Fortunately, saving the day. It has not aged very well, so you don't have to watch it. But that was what triggered my desire to own a computer. And so I told my parents, I really want to get a computer. And my parents said, no. Until one of their friends, a software engineer, not a software engineer, but an engineer at the time, said, well, maybe you should let him have a computer. And to convince my parents that maybe I should, he brought a computer home on one weekend with the manual. Computers came with manual at the time, and said, here's a computer, here's a manual, I'd never touched one before. Learn something, write a program that does this and that and that. If you can do it by the end of the weekend, maybe your parents will let you buy a computer. Super exciting. But it was not over. I had to mow lawn for months before I could afford to buy one. But finally, I could. So that's how I got into computers and what brought me here today. But it's not about me, so it's about Python. And there's a lot of really cool things that people do in Python. Why do I put you towards Spotify? Because a few weeks ago now, that new album was released, and I follow a fair amount of people on Twitter that are involved in the Python ecosystem, especially on the scientific Python side. And the Twitterverse became crazy. And why? Because that little thing here is, oh my goodness, it works. Is the impossible to mistake if you've used the Python scientific stack and matplotlib. It is a graph it's album material now, and it's a chart that was done using Python and using a library, a third-party library that's extremely popular called matplotlib, and also using a Colormap that I'm going to mention very briefly. That's very recognizable for people who are into it, called Viridis. What I love about Python, it's a bit small maybe, but is that it's, and I think that's something I want you to understand and I want you to convey, like a lot of Python is done by volunteer who love the language for whatever reason. They're not always computer scientists and they build really cool stuff with it. John Hunter was one of them. So John Hunter is the father of matplotlib. He was a neurobiologist who passed away recently. And that's one of the things I love about Python is in community and how they celebrate the people who help help us do amazing things in Python. Not everyone is nice on the internet, but it is. Viridis, so that color map I mentioned, so that's pretty much how people recognize that album cover. Is very interesting. So matplotlib came with a default color map, which is renowned to be extremely bad for actually people to analyze data. And so, just like a lot of things in the Python scientific stack, procrastinating PhD students decided that it was a very good idea to create a new color map for matplotlib. It's him speaking at SciPy, which is a scientific Python conference in Austin. In 2015, so he finished his PhD. It took him 7 years, but he came up with a really cool color map in Python. I highly recommend that talk if you're into understanding vision and how people see things and the challenges in building a color map. The other thing that, so I mentioned science quite a bit, and if you've studied physics or if you know anything about physics, like you may know that there's always two sides to, there's always two aspects of science and physics in particular. It's the theoretical side and the experimental side, and quite often you have people who are very good at theory and some people who are very, very good at experimental stuff, and they meet and they fight, and but in the end, like the theory is only good if you can have an experiment to back up and demonstrate that it's real. Why do I mention that? So Particle Fever is an absolutely awesome movie, which illustrates that really, really well. Why do I mention it? Because it's almost of the actions take place at CERN, which is a particle accelerator in Geneva, if you don't know. And CERN is people at CERN use Python quite a bit, and other things, but it was my first Python conference. So I started playing in Python in 2003. And decided to attend the conference. I recommend it if you can. Otherwise, there's plenty of video on YouTube and stuff like that. But attend them. The sense of community and the support is awesome. But so EuroPython 2006, my first conference. CERN, I met people there that became friends and very, very good friends with whom I keep on interacting and working with quite a lot. I also met Guido van Rossum, the creator of Python there. I shook his hand in the bus. I didn't wash for 2 weeks. It was fantastic. Yeah, I'm a bit of a Python groupie. Other people doing, so talking about science, or why I lead into science, because there's a woman who's done some amazing work in physics, in computer science, in physics recently. Her name is Cody Lee. I don't know whether you have heard about her. In 2017, she gave a tech talk, how to take a picture of a black hole, where she was announcing that they were very close to actually being able to do it, and explaining how, and how she contributed to making that possible. 10 months ago, it actually happened. So the experience was, the theory was validated by the experience. It's very, very interesting to try to understand how the work she's done to make imaging possible and without bias to make sure that it was a valid experiment. I recommend the talk highly. Why do I mention it? Because obviously all the work is done in Python. So what she's done is producing images with regularized maximum likelihood methods. It's on GitHub if you care. It's all in Python. It's fantastic. Astronomy, astrophysics, like a lot of people use Python. Unfortunately, a lot of them use Python 2.7, but that's historical. That's the way it is. And obviously, when something like that happened, another source of interesting news and info on Python, like the Reddit became alight, so our Python became alight with, oh, yes, we've discovered a black hole in Python. Like, okay, we use Python to image a black hole, but it's fantastic. So there's a lot of that sense in the community that I would like you to appreciate if you're not already part of it. So we do album covers in Python. We image black holes. It's really, oh man, I should have rephrased that already. It's really cool. Look, Python is an amazing language. There's an old saying that Python is the second best language for everything. Jake van der Plas, if you do Python data science, you may, or if you're interested in it, you want to remember his name. He writes some really cool books and post some really cool blog posts, and it's very, very, very smart and very interesting. I would say, in my experience, it's the second best language for almost anything. I add almost in there because there's a lot of things I haven't tried. There's a lot of problems that I wouldn't even know where to start to solve. But I don't think it's a language limitation per se. It's mostly my own limitation. But so what makes Python so successful, so appropriate, so good a language to, and what makes it the second best language for everything, of almost everything. So the first thing I think is that it has a very, very low cognitive load to work in the problem space. Guido van Rossum, that's him, is the creator of Python. He used to work for Dropbox. He retired very recently. Wrote a really good article on the Dropbox blog about that. I recommend reading it if you're so inclined. But it's really like what he really tried to do was making that possible, making it possible for people to basically do computation. Well, he wanted to have fun first, but let's do computation in a very straightforward way without having to worry about I'm going to upset people here, but a pointer and memory and whatnot, just make it work and it happens. That's how I personally got into Python. So I worked in the textile industry for years, and I had a risk problem, exposure to a large amount of commodities, and I wanted to have a better view on that, and I built a tool to analyze my wool risk in Python. That's how I stepped into the language, and I realized that it was fantastic, and it switched the way my brain works. The other reason why I think Python is so successful, it's standard library. What you will probably hear a lot if you're in a Python sphere or when you get started, is that Python is batteries included. And what does that mean? It means that most Python distributions ship with an extensive library of modules and modules and packages that makes pretty much anything you want to do with a computer possible. I'm exaggerating a bit, but pretty much. The standard library, so basically the Python that comes out of the box is pretty much a very good foundation for to start working from. Yet it's not complete, and it doesn't pretend to be complete. A little library I personally like a lot, and I like the way it's described itself. It's called bolt-ons. When you talk about the standard library, one of the things that people mention a lot is the built-ins, so the things that come built in Python. Bolt-on is a set of pure Python utilities in the same spirit as, and yet conspicuously missing from the standard library. I don't think there's a week where I don't reach for bolt-on to do something. Actually, I don't reach for bolt-on first. I write the Python code to do it, and then I realize that I can just import bolt-on and do it in a nicer way. So I like not having to write code, as long as I understand the dependency and I like the people who do it. So Mahmoud Hashemi is the creator of bolt-on. He's an awesome Python developer as well. If you should follow him if you're so interested. So it's not complete, and it's also not perfect. One of the best examples of that is the request. I would say one of the key examples of that is the request library. In the Python standard libraries, there's a tool called URL-lib, which lets you do pretty much everything you want to do with URLs, universal resource location, by tremendously reducing the scope and also tailoring the usage. Initially, a guy named Kenneth Wright wrote requests, which is a library to interact with the web in general. It's very, very, very nicely done and very useful. And I think that, and again, I want to stress it again. So I mentioned it with Matplotlib, John Hunter, and others. But most of these things, like bolt-ons and requests and whatnot, like were initially and more than likely still like developed by volunteers. I think it deserves respect, and they don't always find it. So I want to stress it again. The other, obviously I mentioned it before. I'm not sure whether you've seen that one. You're flying how? Yeah, Python. So the third-party ecosystem is massive. The third-party library ecosystem is massive. You can do a lot. A lot in Python, and there's a lot of people who've tried to do a lot with the language. It's worth thinking about that. The question is, actually, I'm going to illustrate. I want to illustrate that with an example, personal example. So, 5 years ago, I was working on processing a fair amount of data, and I had a key problem, which was one of the problems I had to be able to scale that thing was to be able to deserialize messages, or deserialize object in pure Python, and I didn't really know where to start to make that faster, and I found a little project. So I actually tried a few, and I found one little project on the internet, on GitHub, called Pyrobuff, which was a way to deserialize Google protobufs. It may be Chinese, but that's okay. So do what I wanted to do using Cython instead of Python. Cython is quite interesting, so you will hear quite often that Python may be slow, and it's true that it's not the fastest language in the world, but there's many ways to make Python a bit faster. Cython is one of these ways, and a lot of the Python scientific stack is built on top of Cython. But anyway, so what I wanted to illustrate is if you want to do something, like there's probably someone who's tried to do it already, and even if their project is not quite ready yet for prime time, like you can help them make it. I feel like that's pretty much what I did with Pyrobuff. So it was just some code dumped on GitHub. I turned it into a proper package, released it on PyPy, made it work for my use case in particular, and it's alive. It keeps like, there was an update 24 days ago. It's fantastic, and I don't use it anymore, but that's okay. So we talked about Python. I think I want to bring it now, bring the subject now, because I don't know when to bring it. When is the right place to bring it, but there's two questions. It's which Python are we using, and which third-party libraries are we using. If I want you to take anything away from this talk, if you like Python and decide to get into it, or if you're already doing it, it's use environments. It's a very, very, very. No, I think it's not a controversial subject. I think everybody agrees that they're necessary. So an environment is a way to isolate, to make sure that you know which Python you're using and which third-party dependency libraries you're using. Since Python 3.3, there's something that's in the standard library to create virtual environments. It's called venv. I have actually never used it. When virtual environments came to be, it was an external project. And I was using it, and then since most of my work involved using the Python scientific stack and on all sorts of platforms, Windows, Mac, and Linux, I tend to use another one which is called Conda. I don't want to start a religion war. They're both very good, they're both very suitable. I like Conda, it's convenient, it works for me. And especially if you end up like using a lot of the, if you work on Windows, I think it's still better than anything else. But again, so get started, but think about environment. If you develop the habit of working inside environments, your life will be a lot easier going forward. How do we start getting into Python? I think before getting into the nitty-gritty bit, I think there's a few things I want to mention. The first one is do not be afraid of the command line. Philippe Guo, again, professor, a really good educator, wrote that blog post a few years ago now called basically talk about command line bullshittery. It's a bit negative, but actually it's quite positive. If you work in Python, like at some point you're going to have to work some magic at the prompt. Do not be afraid of it. It's actually extremely powerful, and it will help you. It will help you tremendously. The second thing I think, which is very important, and most students don't know, but I think version control is fundamental. Learn enough about it. Today I say it's Git. When I first started, it was not. And it may not be Git in 10 years' time, but today it's what you should probably learn. Version control is super useful. It will save your life. Not literally, but figuratively. And I think so, but whether it's Git or something else, like you want to learn something, you want to learn enough about version control to make progress. And lastly, for the generic non-Python specific stuff, like you need to choose a text editor. I think it's super important, and master it. Some people choose Emacs. Masochist, I would say. The enlightened minimalist, like Vim, that's me. Very popular. I use it as well a little bit. No, it's actually very good. Cody is awesome. It's in the generic editors with a lot of plugins. It's an open source project backed by Microsoft. They've got a lot of traction. And very popular. A lot of Python developers use it. If you like to have a little bit more assistance and work more in an IDE, like PyCharm is also it's also an excellent choice. That's out of the way. What's the accessibility of Python makes it, in my opinion, like the best way to get started is to find a problem you want to solve, and then Stack Overflow, because Stack Overflow has the answer to everything. A little bit of time, a lot of coffee, and you have a solution to the said problem you wanted to tackle. And you do that over and over again. Ideally, you speak to people and you show people the work you're doing because they will say, oh man, you could do it better. Oh, I've done the same thing, but I've done it that way. Hacking with friends in Python is awesome, and there's a lot of friends that you can hack with around. But because it's so easy to yield that power, the Python power, I personally think that we need to be a little bit more deliberate about learning and understanding the foundation. Especially, even if software engineering is not your career, but it's what you design yourself to be. But because in the end, like when you work in Python, you work with code. I tend to recommend to the people I help learn Python, like a couple of books. And on the foundation side, like really understanding the language, like I think Python is a very good book. Alain Donnet is a fantastic educator. He wrote books on all sorts of different subjects: complexity, base theory, digital signal processing, Think Java, Think Stats, Think Data Structure. It's really interesting. The Think Python book is really good, especially if you've never touched Python, because it will really help you lay some solid foundation to build upon. And if you come from another programming language, but you want to actually do Python and do Python right, like do Python well, there's no right way or wrong way to do it, but do Python well, it will really help you. You will go through the book very quickly, and it will help you do that well. The other book I love to recommend, and anyone who's doing Python, again, maybe not as a profession, but as a way to do the work they have to do. I find this book, Effective Computation in Physics, fantastic. Skopat and KTF are awesome. Katie is a nuclear physicist. They're both nuclear physicists, I believe. Katie is a professor in, I think it's Chicago University now. Her job is not to write Python code, but she writes a lot of Python to make some nuclear power work for people. She wrote a really good book. It covers everything from the command line to version control to text editors to foundational Python, not so much, and the basic things you need to know to leverage the Python scientific stack. Your NumPy, your pandas, your plotting, and stuff like that. There's even a chapter in there about test-driven development and testing. I recommend it highly. It comes from, so I believe, if I recall, they wrote the book in some ways after they experienced the being part of the software carpentry. Originated in the States. It's the best way I have to describe it. It's scientists helping scientists write better code, because in the end, like someone will have to look at it, and if it's done in the best way, it's in a good way, it's easier for people to collaborate. I did a software carpentry tutorial at SciPy in 2015. Like, I participated. It's really good. Like, it's really foundational and solid. There's a chapter in Australia. I don't think they got anything in Sydney, but they're still alive. They're still doing stuff. If you have a chance and opportunity to attend one, like I would recommend you do so. Another to sort of close the interesting people doing cool stuff in Python and also the learning things. Like I need to mention Lorena Ababa. She's a mathematician. She focuses on aeronautical engineering. She does a lot of amazing things in Python. She's a strong promoter of helping women get in STEM. And in the process, I'm mentioning another conference that's really interesting, and you can find a lot of resources online for it, called PyData. There's PyData chapters all over the world. Here, she spoke in London last year. She was keynoting the conference. The reason why I mention her is because she's the promoter of Engineer Code, EngComp on Twitter, which is basically a set of lessons to help engineering students work with computers and make computers work for them better. I've never used that material, but knowing Lorena Barba, I'm pretty sure it's awesome. And she's not that professor living in a golden tower somewhere. Like, she's actually still contributing to the project. The last thing, so more like really more Python thing. I think it's super important when you work in Python, or if you discover Python, to embrace the REPL. REPL, R-E-P-L, stands for Read, Eval, Print Loop. It's the best way, in my opinion, to learn and to explore and get quick feedback on what you're trying to do and to make the computer do for you. I've heard really good thing about REPL.it for people who get started. I'm going to actually have a crack. Boom. So it's getting to the live stuff. No? We're creating a REPL, and I can show you what it is if you've never seen one. OK, I don't care. Oop. Can you see that? So the REPL is here. You can say I can do whatever, 1 + 1. It's evaluated, and here you say print. Woo. And then if I press run, it should do something there. Oops. Yeah. Anyway, that's the REPL. Maybe REPL it is the things that you want to use to start discovering Python. I don't have any shares. I'm not promoting. I'm promoting it because I think I've heard a lot of people say very good things about it. It's kind of cool. Right. That was my pure Python. Hopefully inspiring you, helping you find a way to make your first steps in the Python ecosystem. My REPL, the one I tend to use is Jupyter Notebook, Jupyter Labs. So I'm going to talk about that. But you must all have a pen and a piece of paper. And before we get going, so last time we ran that a Python session. Like one of the feedback we got was that it may not have been as technical as we wanted it to be. So we're switching to a little bit more technical stuff. But I want to start with a little game, and we're going to play flip a coin. And I want you to imagine that you all have $100. So I would like you to write 100 in the top left corner of your piece of paper, and then. I actually do have a coin. I've got a 50 cents coin that Davis over there gave me before the conference. I want you to pick an amount that you want to wager on me flipping that coin now. So let's say for me it would be $50, and choose a side, head or tail. So let's say I'm choosing tail. Please participate, otherwise it's not going to be funny. Is it readable from the back? Yeah? OK. All right. Have you all had something? It's head. All right. So if it's head, I lost $50. So I only have $50 left. If you'd chosen head, you would have $150. I would like you to write the 50 underneath, and we're going to do another one. So I'm going all in. I'm going to go head. Are we all ready? Yes? Right. Tail. All right. I'm bankrupt. Who's bankrupt? Yes, I'm not alone. Awesome. So we're going to do, basically, I want to use Python to explore a little flipping coin problem, which is marginally related to the type of business we do. So there's no third-party library will be used, no module will be used in that demonstration. I'm going to live code, so I'm going to embarrass myself, but that's OK. So in Python, there's a module in the standard library called random. Oh, actually, I'm going to restart the kernel because I did rehearse, but I don't want to be helped. All right, so we're going to import random, and we can define a function called flip. And what do we want flip to do? We want flip to return head. If random.random. So what does random.random do? It returns a value between 0 and 1, exclusive. So if random.random is less than 0.5, I'm going to return yes. I'm going to return h. Another one I'm going to return. I'm going to move that there. All right. So that's my flip function. And if I call it, I get tail. If I call it again, I get head, tail, head. OK, that's pretty cool. Is it really a fair coin? So we think it's fair, like I've put a 0.5 there, maybe, we'll see. But one of the ways to assess that is to call flip a few times and then make sure that it is. So here I'm building what's called the list comprehension in Python. It's actually inspired by another language called Haskell, but Haskell is too complicated for me. So let's do it 10 times. Oops, what have I done? Oh, sorry. I said I was going to embarrass myself. Okay, so we've got a list of 10 result of flip. Okay, it looks, maybe it's fair, maybe not. Ideally, we want to count the head or tails, the H or T. How can we do that? There's in the Stern library a really good module called collection, which contains a counter. And if you use counter to apply to that list, what do we get? Oh, we have 9 head, 1 tail. Is it fair? Oh, that's weird. Like, could be. I don't know. Let's do it a little bit more time. Very nice notation addition to Python 3.5, I believe. I don't remember. When you have thousands that you can separate with an underscore. When you work with big numbers, it's cool. Yeah, it looks like it could be a fair cone. Like, it looks half decent. Yeah, like that looks fair. So collection, the collection modules counter, really cool. List comprehension, really nice as well. I think they're really nice features. What if we did not want that cone to be fair? Now maybe we want to add a little bias to the mix. What would the bias be? So let's say if I do this, that could work, and then I need to specify a bias. So let's run the function. So now I'd say if I specify a bias of 0.5, the cone will be fair, but if I specify a bias of 0.6, the point will be slightly biased towards head, so head should come up more often. Let's make sure that I haven't messed up my implementation. So if I do 0.5 here, yeah, it looks relatively fair. If I do 0.6, yep, it looks like it's biased towards head. Okay? So the dictionary, like the key H is higher than the key T. When you have functions like that, like one thing I really like, a recent addition to Python, you can have also, so here I say I use 0.5, I have to specify the 0.5, you can also say, oh, you know, I want most cones are fair, so I just want to give the argument a default value, and then you can call it again without bias, and it will just by default use the 0.5, which is very neat. So default argument in Python are really cool. Sometimes you have functions which have many arguments, and you shouldn't have, but sometimes you do. And it's quite hard to remember which is which, and in which order you should submit them. So you can have named argument, and you can force named argument. Also a very recent addition to Python, which is really nice. If I try to run that with nothing, it will work because it has a default value. But if I put a 0.6 there, it will fail. It will tell me, I don't know what you mean by 0.6. You have to specify the name of the variable you want to have. And I think that's really neat. So now if I do this here, so I say bias equal 0.6, I see I've got a bias cone. All right? So we have a nice little function called flip, and we can bias some cones. That's really cool. Let's play the same game, but with a bias cone. All right? So we start with $100, and we're going to do it 10 times this time. So I'm not going to flip. I'm going to run flip here. So I would like you to think about what you want to wager on the next coin flip, and I'm going to do it. Are you ready? So I like to take risk. I'm going to put $50 on head, and we'll see what happens. Are we all ready? Okay. All right. I don't know about you, but I've got $50 left. All right. Okay. $25. Maybe it's in a lucky tail streak. So I'm going to play tail. Are you ready? All right. Let's go. Poof. Tail. Yes. I knew it. So I've got $75 left. I want to run. So we've done this 3 times. Is anyone bankrupt yet? Oh, I like it. All right. I'm going to go all in $50. No, yeah, $50. I'm going to play tail again. Like it looks like tail is coming a lot. Oh, it's tail again. My goodness, I wanted to go bankrupt. All right. $125. Anyone else is bankrupt? More people? Oh, nice. Good. It's going to make the following more interesting. Okay. So I'm just going to clear the output just to prove that it's really running and I'm not cheating. Okay, I'm going to put $100 here because I can. Maybe I'll go ahead again. I'll go ahead. Are you all ready? Those who are not bankrupt, obviously. Head. Yes. All right. Let's do it. A bit more. 200? Okay. Is someone who's bankrupt who told me that? Okay, all right. And head or tail? Head. Head? All right, sure? Okay, let's do it. Let's just clear the output. Okay, are you all ready? Head. Yes! Oh, man, I'm so, like, I really want to go bankrupt. 425, okay.
425 head.
425 head? Are you sure? Okay, oh my goodness. Okay, let's go, let's play that. Be smarter, huh? Like, don't listen to him. We're going to go to 10, huh? So it's, oops. It's head, yes, again. All right. 850 and 850 head, okay. Oh, goodness. Anyone else is bankrupt? Oh, are people still not bankrupt? Okay, cool. Okay. Anyone has more than 850 bucks? More than 850? Anyone? Oh. Okay. Yeah, you do? No, okay. All right, so on what? Head? Again? Okay. All right, let's do it. And again, my goodness.
1700 tails.
1700 tails? Okay, let's do this. We have not many more. Okay, are you ready? Anyone? You all good?
Yes. Oh, yes.
Ah, okay, finally. All right, so I'm bankrupt. Okay, cool. That was we had a good run though, huh? You know, like we. Okay, we have to do 2 more. Take big deep breaths. Let's do it. Are you ready? Everyone? Yeah? Okay. Tail. Yeah, just it happens. All right, so the ninth run is tail. Tail, sorry. And we're going to do one last one. Anyone is still playing? Yeah, okay, awesome. Are you all ready? Okay. I'm going to, it's the last one, so I hope some of you went all in. Are we ready? Go. Head. Cool. Who went bankrupt after the first round? The first flip? Oh, no one. Oh, that's cool. Okay. Who's got more than $100 now? That's a fair thing. So who's bankrupt? Oh, it's not too bad. Okay, all right. Who's got more than $1,000? Okay. There has to be a way to do more than $1,000. All right. So I think it's super. It's very interesting. So what do you think is the best strategy to play that game? Always heads. Yeah, that's correct. Like it was completely stupid to play on tail. Like we know that there's a bias towards tail, so you should like lean towards the bias. What else? 20%. Sorry. Small margins. Small margins. So you tried not to go bankrupt. Yes. How small? 10%. 10%. Okay. Anyone else?
20%.
20. He knows something. 60% on heads. Okay, let's explore. Let's explore that thing. So so we start with the capital of 100, and we're going to wager. So we said 10%. No, actually, let's go 60. We're going to wager 60%, and we're going to do that a few times. So we said 10 times. So rounds for 10 times. And so then I can say, took range rounds 10 times. We're going to say if flip so we always going to wager on head. So we say capital plus equal wager up and else capital. We're going to subtract wager from capital. Sorry?
Wager times.
Oh, yeah, sorry, yep. Thank you. Wager time capital. All right. And let's see what my capital is at the end. Puff. That works. Oh, $2. Really? 60%? Let's do it again. Oh, $687. Who had more than $687? No one. So it might have been a good strategy sometimes. Okay, let's turn that into a function because it looks like there's a little bit of variance in the result we're getting. So we say, let's define a function called game. Took, and we're going to pass a capital. I'll just make it like that. Capital which has default value. The wager. The number of rounds we're going to play. And actually, yeah. I'm going to move that there. Up. I want the wager here, and with no default value, because that's the one thing we're going to change quite a bit, I think. And we're going to return the capital. Oops. All right, $42. Okay, not great. So let's do this. So what do we want to do? Like we sort of want to run like a simulation. We want to assess to have a feel for that variance. So let's do it 10 times to start with. Puff. So what have we got here? Oh, 0, 6, 10, 170, 687 again, 42, 171. Okay, there's a fair amount of variance. And most of them are, some of them are above $100, so our starting capital is not bad.
Can we sort the array as well?
Absolutely. There you go. I get a good feel. It'd be nice to run it with maybe to run more simulations around it. So it's sorted, it's kind of cool, but we may want to have a little bit of more, to do a bit more analysis on that. So let's call that a simulation. Actually, maybe let's do a simulation function. Oh, let's call it a simulation. So we just put that put that list of 100 simulations in a thing, and we want to look at at a few things. So, what is the minimum of simulation? Okay. What's the maximum of simulation? I'll leave with $1,000. That's pretty cool. What else do we may want to look at? Maybe the mean return? Variance, maybe, yeah? So let's just say, again, a new addition to the standard library, statistics. Some would say unnecessary, we have the scientific stack, blah, 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 but it's batteries included, so it ships. So we can say statistics, boom. We're going to look at the mean of the simulation. $334. The mean looks pretty cool, but someone mentioned variance, so I'm actually not going to look at the variance, but I'm going to look at the median because the median will tell me how many, where 50% of the people are. Let's do the median. Oh, $42. So 50% when we wager 60% of our capital, 50% of the people end up with $42. They started with 100, so it's possibly not ideal. We compute all these metrics. So one of the, maybe we want to describe them. So let's write a little describe function, def describe, to which we pass a simulation. And it will return, let's just copy this. Oops, let's make it, I can close that. Everyone knows I went bankrupt. Because of you. All right, and then we say describe of simulation. And we have a function that returns some of the key parameters some of the key metrics we want to look at when we run a simulation of our coin flipping game. Really nice addition to Python. Like when you have a function that returns more than one value, it happens and it's okay, it's cool. But you may want to do something that's a little bit easier for people to use. So we can, in Python, in collection module again, there's something called name tuple, and we can say that summary is equal name tuple. The syntax is a bit dodged, but it works. And so we said we have the mean, we have the median, we have the mean. It's really hard. Path. And all we have to do when we call describe is when you return describe, we will return a summary. And now we have something that's kind of neat. It's a lot easier to work with the result of the function. So if you write a function that needs to return more than one parameter, more than one number or more than one thing, maybe make it addressable, make it more readable and also addressable in a nicer way. So we can say now describe median, and we have something that's pretty cool. So why did we go through all that? Well, because we actually want to see what's happened when we play with different wager amounts. So let's write a simulation function now instead. So it's a def simulation, and we're going to say it has a few arguments. It has a wager argument, and it has a count. Let's do that. Poop. Yep. And it will return that thing with wager equal wager. And the number of times it will do it is count. So now it's count. Oh, that should work. And so now here, when we have our simulation, I'm going to move that there, doc. We can say describe simulation, and our simulation is a function, and we're going to say wager equal 0.1. And we're going to do it 1,000 times. Not bad. 116. We're making a little bit of money. Or the median is positive, so there's more people making a bit of money than losing. Not bad. Obviously, someone knew something. Oh, he's left.
Oh, he went to the pub.
Oh, okay. It's good. He's not going to steal my thunder. All right. So what we want to do now is basically want to do it. We want to do it a few times. Actually, I'm going 1 to 10. Took. So if I do this, I'll show you. That's neat. Pop. We're going to do up, and I want to do it divided by 10. So that gives me the wager I want to apply. So I'm going to say W equal I divided by 10. Oops, sorry. And I want to print F strings. Also, recent addition to Python, very nice. So I'm going to say wager equal. Oops, no, not that way. Down here, wager equal W. Oops. And then the value W. So that we're printing a string, and with the curly braces, it will know that there's something in the scope of that function that's called W, and it will show it in the string. That's really nice. So wager equal 0.1, 0.1, 0.2 to 0.9. And let's just do the median. And so here we can do some function call and whatnot. So we said, what was it? I'm going to copy that because I don't want to have to retype it. Boop. And with wager equal W. What do you think the value will be? Yeah. 0.2. It's likely to be 0.2. Is it? Oh, okay. So 116. So for 0.2, the median is 122. So 0.2 gives us the highest median. It's really nice. What about if we do it 100,000 times instead? Just to make sure, like it was not lucky. Yeah, it's pretty much the same thing. It's actually, so it's a very interesting result. So it's called the Kelly's criterion. 1958. He didn't have Python and he didn't have computers to do it, but there's a researcher at the Bell Lab who came up with did the work on the probabilistic work to find out what is the ideal amount to wager on an outcome when you have an opinion about its probability. Super interesting. The math is fantastic. If you want to just remember, one formula is 2 times the bias minus 1. So 2 times 0.6 minus 1. You should not wager more than that on the flip of a bias coin or on a bias outcome. One of the things that you may have noticed as I was writing all this code is that I didn't write any class. One of the things that I've noticed people do quite a lot when they discover Python and they discover object-oriented programming is they write classes everywhere. It's not necessary. Sometimes a function does the job. Jack Dedrich gave a really, really good talk at PyCon in the States a few years ago. It's entertaining, he's a very good speaker, and there's lessons to learn from what he's talking about. You don't always need to reach for object-oriented programming to get amazing things done. Closing comments. So I've mentioned at the beginning that you've got and I didn't use any third-party libraries in all the code I've written here. We've explored what I think is a very interesting topic. We didn't use NumPy, Pandas, any of the scientific stack. I've got nothing against them, and I use it every day. But if you pursue Python and you want to do things in Python, really work on the foundations, understand the third-party library, and sometimes when you really need to reach for the big guns. Guido van Rossum wrote that literally 2 weeks ago, I think, about contributing to CPython. In one of the myths, he's saying one of the myths of contributing to CPython is you have to have 10 years of Python experience. So he says it's false. You can totally begin contributing with just a few years of experience with Python, as long as you did more than NumPy and Pandas. He's not having a dig at NumPy and Pandas. He's just it's a very specific way to use Python. NumPy has more to do with MATLAB than Python itself. It's very useful, but work on don't forget to work on the foundations as you do amazing things in Python. Another really interesting, so Python is a fine thing to learn now. Don't expect it to be the last thing you learn forever. I think in your path to learning Python, you will learn about learning and what works for you as well. David Beasley is, I would call it educator extraordinaire. He runs Python courses that are mesmerizing. He gives talks that are fascinating. You may encounter him in your Python adventure. Python is fantastic. It's used everywhere. Probably driven, a lot of it driven by its use in the scientific community. It may not be there in 20. It may not be the best thing in 20 years' time, but it's awesome today. And lastly, I mentioned the community a lot, so I want to finish with community. Every month, there's the Sydney Python user group meetup. I don't attend every month, but I attend sometimes. If you want to meet like-minded people, whether they're very experienced or not very experienced, and try to attend one of these. There's usually interesting talks, and you'll meet fellow Pythonistas, and it's awesome. And I'm done.